Hi, this is Anton from the Terra team. In this video, we'll show you how to ingest data into an existing dataset in TDR. Now we're ready to ingest some data. Let's demonstrate each one of these methods. Let's start by ingesting individual files. To ingest individual files, we'll use the Ingest File API, which you can find under the repository section of the Data Repo API page. Make sure you've properly authorized yourself at the top of the API page. If you have, you'll be able to activate this API endpoint by clicking Try It Out. Once you've activated the API, you'll be able to edit the fields within the API and click Execute. Paste the UUID for the dataset into the UUID field, and then modify the request body to have at least the following parameters. The source path, which is the Google bucket of the object that you're ingesting. The target path, which is an arbitrary path the file will occupy in the dataset's virtual file system. You can choose whatever name you like for the folder structure here. This folder will be created by the ingestion process. And the profile ID field, which you'll set equal to the profile ID that you generated when you created your spend profile, or whatever profile ID you've been granted access to. You can also add whatever string of characters you want to the description field to help you keep track of what you're doing. You don't necessarily need a load tag or a MIME type in order to execute this, so we won't use them for this example. Once you click Execute, you'll see the response code down here. There are several example response codes below. 200 and 202 response codes are good response codes. Some common bad response codes are 400, which usually means there was something wrong with the request body, such as a typo, 401 or 403 errors, which indicate a problem with authorization. If you see one of these come up, make sure you check that you've properly authorized yourself. Remember, if you refreshed this page, you may have to log in again. If you're properly logged in and you're still getting 401 or 403 errors, make sure there are no problems with the permissions you have for the dataset, the bucket that you're ingesting from, or the profile ID that you're charging this to. And a 404 error may mean that the dataset you're trying to ingest to doesn't exist. If you get a successful response, the response body will include an ID field that can be used to track the status of the job. To track a job, use the Retrieve Job API endpoint, which is also found in the repository section. To use the Retrieve Job API, simply put in that job ID that was generated in the output from whichever job you just launched into the ID field in the Retrieve Job API. Once you execute it, assuming the job ID you're using is correct, you should get a response code that will tell you whether or not the job was successful, is still running, or failed. Now let's talk about ingesting files in bulk. If you want to ingest many files at once, you have multiple options. You can use an array-based method, in which you build a single JSON and paste it directly into the request body of the API. Or you can use a file-based method, which can be useful if the batch of files that you're ingesting is so large that writing out a single JSON including all of the files is unreasonable. Let's start with the array-based method. This method uses the bulk file load array API in the repository section of the API page. In addition to the spend profile ID, the request body will have to contain a load tag, which is a unique identifier for the batch of files, a load array, an array of individual file ingest requests. This is just a comma-separated array of the same text in the request for single file ingest, multiplied by however many files you're ingesting, and a max failed file loads field. This is just an integer setting the number of failures that should be permitted before the bulk ingest is stopped. In this example, I set the max failed file loads to 1. I set the load tag to be some string that will be easy for me to remember, and then I write out a JSON object as the input for the load array. The JSON object contains two nested JSON objects within it for the two files that I'm ingesting in this example. Each object has a source path, a target path, and a description string. The source path is the path to the bucket where the file is coming from, and the target path is the same as the target path in the previous example. In the previous example, using the Ingest File API for ingesting individual files returns a response code that contains the ID for that file. When you do it this way, there's an extra step needed to retrieve the file IDs that you'll need to put into the CSV you later use to ingest metadata pointing to these files. In order to retrieve file IDs, you'll need to remember what you set as your load tag parameter. This is why it's a good idea to make your load tag something simple and easy to remember. To get the file IDs for the files you've just ingested, go to the Get Load History for Load Tag API. This one is found in the Datasets section of the API page, as opposed to the repository section. You can then use the load tag that you yourself set when you executed the bulk file load array API, along with the UUID for the dataset where you ingested those files. Once you successfully execute the Get Load History for Load Tag API, the response body for this API will contain per file summaries of each file ingested with that load tag, along with file IDs for each one. Instead of the array-based method, you can choose to use the file-based method. To do this, you'll use the same API endpoint as in the previous example, which is the bulk file load API endpoint. But instead of a load array parameter, the request body for this case expects a load control file. The value for this key must be a Google bucket file path, pointing to a new line delimited JSON file, with one file ingest request per line. The requests must be objects with the same keys as the array-based loading request. So an analogous example to the one we just did for the array-based methods would look like this. Instead of a load array, we have a load control file field. The request body may seem much simpler because all it has is a profile ID max fail file loads, a load tag, and the load control file path. The file itself, which is located in the bucket location that you're pointing at, should look something like this. Here again we have two objects delimited by new lines. Each line has a source path, a target path, a description, and may also need a MIME type. The response body returned by a successful file bulk ingest job currently contains only summary information about the ingest. For file-level detail on the ingest process, you'll need to look at the associated BigQuery table through the console. Now we'll look at how to ingest data by CSV. We'll need to start by creating a spreadsheet using software such as Microsoft Excel or any spreadsheet software that can generate a CSV file. In this example, we have a leading row, aka a header, and a leading column. Any placeholder will do in this example, but a column to skip from the left may be necessary. Make sure that the column headers correspond to the columns set in the schema for that dataset. Make sure that the metadata you put in each cell corresponds to the data type you set for that column according to your schema. To point to any files you've ingested in the previous steps, paste the file ID corresponding to the file ID field returned in the response body of those APIs. If you want these to show up as links to cloud paths when you're looking at this either in the TDR user interface or the Terra user interface, make sure the column the file IDs are going to had the data type set as file ref in the schema. Upload this to a Google bucket that has the necessary permission to ingest data to a dataset, and then go to the Ingest Dataset API endpoint, which you'll find in the repository section of the API page. Enter the UUID for the dataset to which you're going to ingest, and execute the API request with a request body that looks like this. In this example, I have the format parameter set to CSV. I have a load tag which I've chosen. The path parameter is set to the bucket that contains my spreadsheet. The table parameter is set to one of the tables defined in my schema. The profile ID parameter is set to my spend profile ID. Max bad records is set to 0. CSV allow quoted new lines is set to true. CSV quote is set to the pipe character. CSV null marker is set to NA. And CSV skip loading rows is set to 1. Some important things to remember here is that the format must be set to CSV, and it's important to set the CSV skip loading rows parameter to 1 in this example because we want to skip the leading row and column of the example spreadsheet we described above. The process of ingesting metadata by JSON is essentially identical as by CSV. you use essentially the same request body. In this example, the format is set to JSON. The max bad records are set to 0, and otherwise the parameters are set the same way as in the previous example. The path then points to a JSON file, which should be in the format of a new line delimited JSON. Another example of the JSON approach is that it allows you to ingest nested arrays of columns. In the next and final example, we'll show you how to use this method to ingest both the files and the metadata at the same time. In this simpler example, we're using a JSON to ingest just metadata, and the JSON that would be analogous to the CSV example we just showed would look like this. You can see here we refer to the column names as defined by our schema, and each of those column names is a JSON parameter, which we set in this JSON. The first column, which is the leading column that we'll skip, can have any name. The second column is the one we'll want to have a proper sample ID. And the third column, the BAM file path, will contain the file ID, which is the identification number for the already ingested file. If your schema has this column set as FileRef for its data type, and you've successfully ingested the file you wish to point toward, this field will render as a GCP bucket hyperlink when you export a snapshot with this row to a workspace. Again, you can get the file ID from the result body of the API you use to ingest the file, or from the Retrieve Job Results API, or the Get Load History for Load Tag API. Finally, let's take a look at how to ingest both files and the corresponding metadata at the same time. If you want to do a combined file and metadata ingestion using only one API request that populates a dataset with new rows, including file paths to files, and corresponding metadata, you can do this using the same Ingest Dataset API endpoint in the previous example, only with a slightly more structured JSON. You would follow the same procedure as in the previous example, creating a new line delimited JSON and uploading it to a bucket, from which you would grab the URL path to that file and use the exact same request body as shown in the previous example. The only difference is that the JSON you'll upload will have a slightly more complex structure, with the column designated as your FileRef data type column containing a full JSON object as its input. So whereas in the previous example, our BAM file path contained a single file ID, in this case, the BAM file path parameter will be set equal to a full JSON object with multiple parameters nested within it. This second nested JSON object contains 4 fields: a source path, which is the URL path to the file that column will point to; a target path, as before this is an arbitrary location within your data repo virtual file system; a description, which is an arbitrary string of characters; and a MIME type. In this case especially, this field is required because of how GCP works. It can be set to text/plain, so long as the data type of this column is set as FileRef in the dataset schema. The column cell will render correctly when a snapshot containing it is exported to a workspace. The only other thing to note about this JSON is that the whole JSON needs to be a single line with no line breaks, as shown here. This means that if you're creating JSONs for ingestion programmatically, you need to avoid creating line breaks. You can accomplish this by either writing your JSON manually, or you can also use a CSV to JSON converter like this one. Our documentation contains instructions on how to generate the JSON in this tutorial. This concludes the tutorial on ingesting data to the TDR. You can find all of these steps outlined in detail with visuals and copy-pastable code examples in the Terra Data Repository section of our support documentation. Thank you for listening.